Hello everyone, I'm Bhavani Shankar Uppari, professor at Singapore Management University. I'm going to talk about off-grid lighting models today. The project was conducted in Rwanda in collaboration with Sergei Natasin and Joanna Popescu, who are professors at Wharton and INSEAD, and with Rowan Clark, who is the research director at Nuru Energy. Nuru was our field partner in Rwanda, and Rowan is currently pursuing his PhD at Harvard. To see why these off-grid lighting models are important, let's take a look at the image of the world taken during nighttime. As we can see, the entire world is well lit except for Africa. It's dead dark there. In fact, it's disappointing to know that 1/10 of humankind still does not have access to electricity. And as we just saw, the problem is much more severe in Africa, where more than half of the continent is not connected to the national grid. Currently, the poor people who live in these areas rely mainly on flame-based lighting solutions such as kerosene, paraffin, and candles, which are not only bad for the health and the environment, but they're also costly in the long run. World Bank estimated that the poor spend currently close to $37 billion annually on this low quality lighting solutions. But what is surprising to me is that this money is so much that they can actually afford better solutions such as solar. So the question is, what is restricting them? To answer this question, let's take a look at a typical household in Africa, and specifically Rwanda, which is our research context. Rwanda is a small landlocked country, 12 million people, more than 60% of them lack access to electricity. Of the remaining 40%, 30% are on the grid, 10% get some form of energy through off-grid solutions. The country is very hilly, as you can see in these pictures here, and that's what makes it even more difficult to fully extend the grid. By 2024, Rwanda targets to put 50% of its population on grid, and for the other 50%, they want to provide energy through some form of off-grid solutions. So as we can imagine, there is a huge demand for off-grid lighting solutions in Rwanda and its neighboring countries too. A typical household in Rwanda looks like this. They are rural, they are subsistence farmers, rely on low and uncertain income sources, earn just $1 to $2 per day, which mainly serves their basic needs. On top of it, they do not have access to effective borrowing and saving mechanisms, which impose tight liquidity constraints in their lives. This explains why the poor do not tend to invest in solar-based solutions, as solar requires high upfront investments, and these people do not tend to have that kind of money at any point in time. Now, I'll show you a technological solution that targets to provide light to a liquidity constrained population like this. It's by a company called Nuru Energy in Rwanda, started by an INSEAD alumnus. It manufactures and sells these rechargeable LED lamps. Each lamp costs Nuru about $6 to manufacture, but is sold at $1 to $1.5. The remaining $4.5 to $5 is recuperated in the form of recharges. So a consumer purchases the lamp, uses it until it's discharged, then goes to a village level entrepreneur who's sitting there with a stationary bike. He attaches the lamp to the bike, pedals it for about 20 minutes. The lamp gets charged. The consumer pays the recharge fee to the entrepreneur and starts using the lamp again. The recharge fee is currently 100 Rwandan francs, which is about 12 cents. And the consumer gets 18 hours of light in return. So these recharge payments are in the form of micro payments, which eases the liquidity constraints of the poor there. And the recharge fee shared 50-50 between the company and the VLE. For this innovative business model, Nuru won several awards and grants. There are several other companies in Southeast Asia and Sub-Saharan Africa which actually operate on a similar business model, but we worked closely with Nuru because of our INSEAD connection, where I was a PhD student earlier. This is Samir Haji, the CEO of Nuru, touring us around Rwandan villages. There's a typical retail store which sells alternative lighting solutions such as a torch that is shown here, and there's a typical kerosene lamp that people use there. Using any of these alternative solutions is costlier than using Nuru's lamps. For example, in this village, I noted that 100 ml of kerosene costs 100 Rwandan francs, which is same as the recharging price of Nuru, but kerosene lasts only for about 6 hours, whereas Nuru lamp lasts for about 18 hours. So in this village, using kerosene is 3 times costlier, and in some other villages, kerosene can be even 6 to 8 times costlier. Our research collaboration with Nuru stemmed from the following business challenge. As I just mentioned, using Nuru's lamps is cheaper than using any of the alternative lighting solutions. Our field surveys and initial experiments also showed that the take-up of these lamps is reasonably high, and the consumers were satisfied with its quality too. However, the usage rates that we observed in the field has been lower than expected. When we started the project, the recharge rates were around 1.2 to 1.6 times per month per household, which was just not enough to sustain the business. So our primary quest was to understand what is contributing to this low adoption. Is it that the recharge price is high? Or is it that it's convenient for the consumers to recharge their lamps? Remember that unlike grid and solar-based solutions, consumers here need to travel to a dedicated recharge center to recharge their lamps, which might cause them inconvenience. Some actually feel that inconvenience doesn't matter to poor people when compared to money, but we wanted to explicitly test whether inconvenience matters or not in our study. There could be several other behavioral factors too that could be driving low adoption, but in this talk and in this project, I will just be focusing on these two factors. We explored a variety of other factors in our other related works. A second most important question for us is, given that there are these factors that are hindering the adoption, what can we do to profitably serve this market? Okay. So these two questions give us the following two-part research agenda. First, we want to quantify the impact of recharge price and inconvenience on the recharge rates and revenues that are generated. We want to measure this impact as purely as possible, so we conduct field experiments wherein we randomly vary the prices and the distances to the recharge center to measure the impact. But we do not want to just stop there. We also want to look into different strategies that address consumers' inconvenience and liquidity constraints and predict how much improvement they are going to bring to us. For this purpose, we build a predictive model. In the remaining time, I'll briefly give you an overview of the field experiments, the predictive model, and some insights that we got from this entire exercise. So the experiments were conducted in 29 villages of the Ruhango district of Rwanda. They were a total of 2,500 lamps. We had 80 to 90 households per village and gave one lamp per household. We randomly assigned consumers to different price levels ranging from 0 Rwandan francs to 120 Rwandan francs. The locations of the recharge centers were also almost randomly chosen. So the consumers, the distances that the consumers had to travel were also randomly allotted to them. Well, it was quite challenging to conduct these experiments in very remotely located villages of Rwanda. But what was even more challenging was to get the data back from those experiments to us in an automatic manner. So we had to enable all the recharging devices with GSM technology so that whenever a lamp is attached to the device, it records the ID of the lamp and the timestamp of the recharge and puts it on the GSM network, from where it gets downloaded to our cloud database automatically. Okay, so what did we learn from these experiments? In the interest of time, I'm going to show you only two primary results that are captured by these two figures. These figures show that the recharges drop sharply as the price and the distance from the recharge center increases. So I'll note few important things here. Even when the price is 0, the recharge price is 0, we see that the average number of recharges per household is 6 over a span of 3 months of experimental duration. So on average, 2 recharges per month, which is not sufficient to sustain the business model. This also shows that there are frictions beyond price that are hampering the adoption. And on the right side, we see that inconvenience is another major friction in the business model. The numbers here say that on average, half a kilometer increase in the distance from the recharge center is resulting in a drop of 1 recharge per household, which is quite significant in my view. The overall reading from these figures to me is that the recharge price, consumers' liquidity constraints, and inconvenience are significant drivers of inefficiencies in the business model. So the next question to ask is, what can we do about them? Well, there are several things that we can do to address these factors. For example, we could just drop the price or give consumers more hours of light per recharge. We could address inconvenience by putting in more recharge centers in a village, or encourage consumers to pool their lamps for recharge while taking turns. Or instead of making consumers walk to the recharge center, we could make VLE, the village level entrepreneur, travel to them periodically, either going door to door or only to some specific set of locations. Alternatively, we could alleviate consumers' liquidity constraints, which is essentially giving consumers a lot of payment flexibility. We could do that by allowing consumers to partially recharge their lamps instead of fully. We could allow them to prepay for the recharge. We could allow them to recharge on credit or repay in micropayments. Note that all of these are what if questions. And we cannot answer these questions by just going and implementing these strategies in the field. Because remember, we are dealing with remotely located villages. So implementation is both time and money intensive. Ideally, we want to know how these strategies are going to perform before they are implemented in the field. So we are dealing here with a prediction problem. One can imagine that for such a prediction exercise, we need a model that closely imbibes the features of consumers' decision-making process and her decision-making environment. So therefore, we actually build a model of consumer behavior under the status quo business environment and estimate it using the data from our field experiments. So the model is quite sophisticated. This model accounts for several important contextual details such as consumers' disposable income, her sensitivity to experiencing inconvenience and blackouts, her light consumption patterns, and her dynamic decisions regarding whether or not to recharge her lamp. We also designed our field experiments in such a way that all the parameters of this model can be estimated using the data that we collect. So we make use of a bunch of methodologies here, ranging from stochastic dynamic programs and renewal theories to statistics, structural econometrics, and a bit of machine learning too. Although these are all crucial details, I'm skipping them all in the interest of time to give you an overview of what we do and what we find at a big picture level. Those details, we can always discuss them offline and they can be found in our paper too. Okay, so once we have this model and it is estimated using the field experiments, and once we have the parameters of this model, we can start asking it the what if questions. Say we want to know how things will look like under an alternative business environment. As I said earlier, our model captures the primitives of consumer behavior. So it is quite flexible and can be contorted in different ways to represent the consumer behavior under alternative business environments. So using the behavioral model under the new business environment and using the behavioral parameters that we estimated earlier, we Monte Carlo simulate this environment and see how things will look like in this new environment. Things could be, how could the recharges look like in that environment? How will the revenues look like? How will the profits look like? Okay? So these are all the things that we're interested in. And this is the overall framework that we use to answer our what if questions. And one can think of this framework to be a business model query engine. We can ask this engine how a business model change will perform, and it gives us an estimate. We ran this engine for a plethora of alternative strategies. And next, I'm going to show you just a sample of our results. First, I want you to focus on the two benchmark cases here, wherein we either completely eliminate inconvenience or liquidity constraints from the business model. These benchmarks showed tremendous improvement in recharge revenue relative to status quo, which reaffirms that these two factors are major contributors to inefficiency in the current business model. However, achieving these benchmarks will require implementation efforts towards a completely, for example, an on-demand door-to-door recharge service, or designing a fully flexible payment scheme, which may or may not be practical right now. So we can think of this as more of a long-term strategy. So currently we can go for several short-term strategies that are simpler to implement, like the ones that I discussed 2 slides back. And the model is going to give us the performance predictions for all of those strategies. And I want you to note that some of these short-term strategies are quite powerful. For example, by making the VLE travel door to door once a week, or travel just to 5 locations in a village twice a week, we capture half the benefits from completely removing the inconvenience. Similarly, by allowing the consumer to recharge on credit, we capture more than half the benefits from totally alleviating liquidity constraints. So some of these strategies are quite powerful. One more important thing to note, a natural response to low adoption when we're dealing with poor people is to usually drop the price. But what the model says is that playing with prices is not going to bring us good revenue improvements. Instead, we are better off fixing the inconvenience and liquidity constraints by making simple changes to the current business operations. Also see that allowing partial recharges is not that effective compared to other strategies. So it's better to prioritize these other strategies compared to partial recharging. Although I'm not going into all the details here, one can imagine that using estimates like this, we can design short-term and medium-term plans for the firm by optimally prioritizing and combining different strategies so that we can break even first and then to make profits. I'm going to conclude the talk now with some key takeaways that for us from this entire exercise. As we saw, simple changes to the business operations, as opposed to simply just blindly dropping the price, making changes to the business operations can achieve quite good performance. The template that we used here allows us to predict policies, performance of the policies before they are implemented. Similar approach can be adopted in other contexts also to come up with efficient and effective business models that serve the poor. And what we need for that purpose is not necessarily big data. We can survive with small data too, like us. But what we need is smart model. And finally, there is this notion that inconvenience does not matter to the poor consumers. Our study conclusively shows that inconvenience matters to the poor, and time is money, even under poverty. With this, I want to thank you.